Now, you know, according to Pascal's triangle, 1 plus 1 is 2, 1. 1 plus 2 is 3, 2 plus 1 is 3, then a 1. Okay, so you put a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1. So this is row 1, row 2, row 3, row 4, row 5. So this is the row that I'm going to be using. All right, so what I'm going to do is I'm going to put those coefficients, I'm going to write those coefficients down. I'm going to 1, and then I'm going to leave some room. 4, leave some room. 6, leave some room. 4, and then I'm going to leave some room and put a 1. All right, so let's see if I can get this stuff right here out of the way. Okay, I'm going to pull that way down there. Okay, so the first step that I did was I wrote down all of the coefficients from Pascal's triangle. All right, now what I've got to do, and I need to point out to you that because this is negative, these are going to be alternating signs. Okay, so I'm going to take, and this is going to be 1 times, and I put a parentheses around the 2x. That's going to be important for you to include because that's showing your work. So the first term, which is 2x, raised to the 4th power, okay? Then the second term, which is negative 3y, gets raised to what power? Correct, okay? Then I'm going to put a plus right here. Then I'm going to take the second term, which is 2x, and that's going to be raised to what power? Awesome sauce. Okay, and then the next term, which would be negative 3y, and that's going to be raised to what power? That's right, to the 1. And then I put a little plus. I really should have stretched out the numbers a little bit more. All right, so then I'm going to take the first term, 2x, and that is going to be raised to the, see how the first term decreases. 4, 3, 2. Okay, let me move this out a little bit. So the first term is raised to the 2, and then the second term, which is negative 3y, is going to be raised to the second term. These two have to add up to be 4 every time. 4, 0, 4, 3, 1, 4, 2, 2, 4. And then I'm going to put a plus. I think you're following despite the fact that it's all crunched in there. So then this is going to be, I'm going to take 2y, and I'm going to raise that to the 4, 3, 2, 1. And then I'm going to take the second term, which is negative 3y, and that's going to be 0, 1, 2, raised to the 3. Then I've got plus. And then and my leading coefficient here is 1. So I take the first term, 2x, and that's going to be 4, 3, 2, 4, 3, 2, 1, 0. And then I take my second term, which is negative 3y, and that's going to be 0, 1, 2, 3, boom, 4. Okay, now this is the tough part. Setting it up using Pascal's triangle and making the terms decrease and then making the second term increase, that's a snap. The hard part is figuring out what in the heck is going to happen here. All right, so okay, so I'm going to do this first term, because this is where everybody makes their mistakes. 2x to the 4th is actually 2x times 2x times 2x times 2x. So the biggest mistake that people make on this honors extension activity is they just write 2, okay? They don't think that 2 is being raised to the 4th power, but it is. So I have to consider all of this. This is 2 times 2 times 2 times 2. It is 2 to the 4th power, which is 16. And then there's 4 x's, so 16x to the 4th. So this part, you know, I can bring down my 1 times what I got for this part was 16x to the 4th. And then this part, well, anything raised to the 0 power is just 1. So this simplified to just 1. So that means that my first term in this expansion is 16x to the 4th. Okay, so now that was positive, okay? The next one is going to be negative. The next one is going to be negative. Okay, so let's take a look at the next one. So I've got the 4. I can't forget about the 4. And now I need to pay attention to what 2x to the 3rd is. Well, that's 2x times 2x times 2x, just 3 of these. So 2x to the 3rd is actually 8x to the 3rd. So that means that this part simplifies to 8x to the 3rd. However, this part is negative 3y. Okay? Because it's raised to the 1 power. So now I've got 4 times 8 times negative 3. Well, 4 times 8 is 32. 32 times negative 3, I think, is 108. But it's negative 108. I need you to check me on that. What is 12 times? No, 12 times 8 is 96, not 108, 96. So this is going to be negative 96 x to the 3rd y to the 1. Do you see how they're still adding up to 4? See how the powers are still adding up to 4? That's what's really cool to me. Okay. And then we just keep going with this process here. We've got a 6. We've got to write that down. 2x squared. Well, 2x squared is 2x times 2x, which is going to be 4x squared. That's this part. Negative 3x squared, well, that's negative 3y squared. That's negative 3y times negative 3y. I'll write it down right here. Negative 3y times negative 3y. That is positive 9y squared. So now I go 6 times 4 times 9. That's 24 times 9 or 54 times 4. I'm going to do that. 54 times 4, that's 16, carry the 1, 216. So that means that the number here is plus 216 x squared y squared. Exponents are still adding up to 4. Notice, though, that this one was positive, this is negative, this is positive. The next one is going to be negative. And the reason I knew that was going to happen was because of this thing right here. That negative in between there makes it alternate. Okay, so then I'm going to put this plus right here and right here, okay. And I'm going to drop the 4 down. Let me get rid of this junk, all this junk right here. Get rid of that. Okay, so I'm going to put the 4 down. And this is 2x to the 1 power. That's not 7. That was 4, 3, 2, 1. Okay, so this is 2x. 2x to the 1 power. Negative 3y to the third. Okay, so I think I can write that right here. Here's negative 3y times negative 3y times negative 3y. Okay, well, negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Good, good, good. And this is going to be y to the third. So what I have here is 4 times 2 times negative 27. 8 times negative 27. I know it's going to be a negative number, okay? I know it's going to be a negative number because positive, positive, negative means negative. So I'm just going to put a minus right here, save me a little bit of, okay, then I've got 8 times 27. So over here on the side, 27 times 8, that's 66. 16 plus 5 is 21. So now I've got minus 216 x to the 1, y to the 3. So if you're noticing here, the variables do not really pose the problem. The variables are always, your first term, it's always going to be x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. And then the y is going to be y to the 0, y to the 1, y to the 2, y to the 3, y to the 4. So the variables are not really the issue here. The issue is what is that number that's going to go there. And that all depends upon which row in Pascal's triangle you're working on and what are these numbers right here. So there's no real way for you to predict that without going through the motions of actually figuring it out. Okay, I wish there was a shortcut. It would be super easy if those numbers were 1, because then just everything would be 1. But unfortunately, it's not 1. It's not x minus 3. It's 2x minus 3y. So it's kind of a pain in the rear. So this one was negative, so I know this next one is going to be positive. They always alternate, you know, plus, minus, plus, minus. Sometimes it's minus, plus, whatever. Okay, so now I'm looking at the last term. Okay, so I've got my coefficient of 1 that came from Pascal's triangle, 2x to the 0 power. What is anything raised to the 0 power? It's 1. So anything to the 0 power is 1. So I've got 1 times 1. Okay, that's a bit redundant. Then right here, negative 3y times negative 3y times negative 3y times negative 3y. So basically, I know that it's going to be y to the 4th. So really all I have to think about is what is negative 3 times negative 3 times negative 3 times negative 3? Okay, well I know that that is going to be positive. So now all I have to worry about is 3 times 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. You are on top of this. You did not need my help with this. Okay, so this is 81y to the 4th. And I got to tell you, that is a lot of work. Okay, that's a lot of work. But I can promise you that it is faster to use Pascal's triangle and binomial expansion than it is to write this sucker down 4 times.